Okay, so in this video here, we're going to be talking about how to solve a 3x3 system of equations. Now, in order to do this example here, you're going to have to know how to solve a 2x2 system of equations, which I have a video on. So if you don't know how to solve a 2x2 system of equations, go ahead and check out my videos on that. I'll go ahead and link them in the description box below. I have videos on both elimination and substitution, solving a 2x2 system of equations. So you have to be proficient in that first before you can try this video. But if you can solve a 2x2 system of equations, you can definitely solve a 3x3 system of equations. There's just some more steps involved, all right? So the main goal when you are solving a 3x3 system of equations is to bring it down to a 2x2 system of equations. By bringing it down to a 2x2 system of equations, you're then going to solve it just like you normally would with a 2x2. So how do we do that? Well, I have three equations here. And I'm just going to go ahead and label all of them. So this is going to be equation 1, equation 2, and equation 3. So from the start, you have to pick a variable that you want to eliminate, okay? Now I'm looking at equation 1 and 3. If I do subtraction, I will eliminate those y variables. 4y minus 4y, that will eliminate. And then I can use two other equations to eliminate the y variable as well. I could also do the same thing with z. Look at equation 2 and 3. I have a positive 3z here and a negative 3z. If I add these up, those will cancel out. So I think what I'm going to do here, I'm going to eliminate z. It's not a right or wrong way to do it, okay? But I'm deciding that I'm going to eliminate z. If you want to eliminate y, go for it. Heck, if you want to eliminate x, you can do that too. All right, but I'm going to go ahead and eliminate z. So I'm going to do that with equation 2 and 3. So what we're going to do down here, we're just going to write 2 and 3. And in order to eliminate those variables, we have to do it as an addition problem. So just rewriting the equations, I have 3x plus y plus 3z equal to 5. Okay? Then if I take a look at equation 3, I have negative 2x plus 4y minus 3z and then equal to 5, okay? So we're going to do elimination and we're going to add. So 3x plus a negative 2x, that will give you x. Y plus 4y, that's going to give you plus 5y. This will eliminate, that's what we want. And then 5 plus 5, that will give you 10, so equal to 10, okay? So there's part of my 2x2 system that I'm bringing it down to. I have it in terms of x and y now. Now I have to pick two other equations and I have to eliminate z. That way I have another equation in terms of x and y. So I already used 2 and 3. This time I'll go ahead and use 1 and 2. You could use 1 and 3, it doesn't matter. But I'm just going to use 1 and 2. All right, so 1 and 2. And now think about it. If I'm going to do this as an addition problem, I mean, I could do it as a subtraction problem, but seeing that this is a positive and this is a negative, it's going to make sense to do an addition problem here. I have to multiply that top equation by 3. Okay, so equation 1, I have to multiply everything by 3 so that my z variables will cancel out. Okay, so that's exactly what I'm going to do. And you can make a note of it. Just put an arrow on 1, meaning equation 1, and just put in parentheses 3, meaning you're going to multiply equation 1 by 3. All right, so if I do that, 3 times 4x, I get 12x. Okay, remember, you have to multiply all of your terms. So plus 12y. Here we get the negative 3z. That's what we need. And then equal to 21, right? 3 times 7, we get 21. Equation 2, I don't have to do anything with. So 3x plus y plus 3z equal to 5. Okay? So now we're going to go ahead, do elimination, and we're going to add it up. So 12x plus 3x, I get 15x. 12y plus y, I get 13y. This will cancel. Equal to 21 plus 5, I get 26. Okay? So what you have now is a 2x2 system of equations. Here's one of them, and here's the other one. So those are going to be my two equations, and I have two variables, x and y. So we're going to go to the next page now, and we're going to solve both of these equations by doing the 2x2 method. Okay, so here we are on the next page, and I just went ahead and rewrote those equations that we formed. Now, again, we can call this equation 1 and equation 2. What variable do we want to eliminate here? So again, you want to pick the path of least resistance. Well, my y variable, that doesn't look very friendly, right? I don't really want to work on changing both of these equations here. to match up those y variables. But x looks pretty easy. If I just multiply the top equation by 15 and I do subtraction, I will be able to cancel out those x variables. So right here, I'm just going to multiply the top one by 15. Okay, so when I do that, I'm going to have 15x. 15 times 5, you're going to get 75. So plus 75y equal to 15 times 10, you get 150. Okay. Now the bottom equation, I don't have to do anything with. I just have 15x plus 13y equal to 26. Now again, we're going to do subtraction here, right? So going ahead, doing elimination, we're going to subtract 15x minus 15x. That will cancel. That's what we want. Now we have 75y plus 13y. That's going to give you 88y. So 88y. And then 150 plus 26, we're going to get 176. So 176. And now from here, all we have to do is divide by 88. So if I divide by 88, I'm going to get my y variable. Okay, so this will cancel. 176 divided by 88, we end up getting y is equal to 2. So y is equal to 2. So that's the hardest part because now you're going to go in reverse to get all the other variables. So now we go back up to these two equations that we formed. I'm going to plug in y into one of those equations and I'll get x. It doesn't matter what equation you pick. Now this one looks way easier. So I'm going to go ahead and use this one and I'm going to solve for x. So I'm going to have x plus 5. Now here's my y. I'm going to plug in a 2 equal to 10. And here I get x plus 10 equal to 10. If I subtract 10 on both sides, I get x is equal to 0. Okay? So x is going to be equal to 0. So we have 2 out of the 3 variables. Now we go back to the original equations and we can solve for that last variable. So why don't we go ahead and do that? So here I am back on that first page because again, we're going to use one of these original equations. And why don't we go ahead and list out the variables that we have so far? We know that x is going to be 0. So x is equal to 0 and y was equal to 2. Okay, so let's box that in so we don't forget. We now have to get that last variable, which is going to be z. Now pick any of the 3 equations, it doesn't matter, and you're just going to plug it back in and you'll solve for z. And so again, what I'm going to do here before I plug it into one of these equations, I'm just going to go ahead and clear some of the space. That way we have room to do the problem. So just clearing this out. That way we have room. There we go. And now we're ready to go. So if you look at equation 1, that's super easy, right? If you look at equation 2 and 3, it looks like there's going to be more work involved. So I'm just going to pick equation 1 and I'm going to plug in my variables x and y. So if I do that, I get 4 times 0, that's my x, right? Plus 4 times my y, which is going to be 2. And then minus z, that's what we're trying to solve for, equal to 7. So this term right here is going to cancel out because 0 times anything is 0. Then we get 4 times 2, that is 8. So 8 minus z equal to 7. Now all I have to do is subtract 8 on both sides. Okay, I get negative z is equal to 7 minus 8, that's negative 1. I do have a negative here though, so if I divide both sides by negative 1, I get z is equal to positive 1. All right, so why don't we go ahead and record that? Z is going to be equal to positive 1. Now, you could actually write it as a point in 3-dimensional space, and that's going to be x, comma y, comma z. So as a point, you could write it as, in parentheses, 0, comma 2, comma 1. And that would be fine too. Okay, so there's your solution right there. All right, so that is how you solve a 3x3 system of equations. Again, it's not too bad. If you know how to solve a 2x2 system of equations, you can definitely solve a 3x3. And when you start doing 3x3 system of equations, you can actually solve them using matrices, which is a different subject that we're not going to cover in this video. But there's definitely different routes you can take to solve these problems that could make it easier. All right, so that's going to do it for this video. I hope that you found it helpful. I hope that you gained something from it. If you did, in fact, gain something from this video, or if it helped you, if you could just go ahead and give it a thumbs up, that would be greatly appreciated. Also, make sure you subscribe to this channel so you get more math videos in the future, and I'll see you in the next one.